video and re-listen to how we came up with our equations. So Julie averaged 85 on the first 3 tests of the semester. How do you calculate an average? Add them up and divide by 3. So her first 3 tests, when she adds up that total number of points, so I'll use T for total number of points, and divides by 3 tests, she gets an 85. So there are lots of different ways to average an 85 on 3 tests. The total points accumulated on those 3 tests, though, times 3 times 3, needs to be 85 times 3 is 255. So far she's accumulated 255 points on 3 tests. This tells us that she's taking more tests. If she scores a 93 on each of the remaining tests, her average will become a 90. Okay, so far she's got 255 points on her 3 tests. She's going to score and add a 93. How many more times? How many more tests does she have to take? What'd you say, Jordan? We don't know. So she's going to get a 93 X more times. Well, actually, let's use capital T because they say determine how many tests, how many more tests are left. So we'll use capital T because they told us to. And when you add up all those total points, how many tests will she have taken? How many did she already take? 3. And how many more is she taking? T. So what expression is going to give us the total number of tests that she's taken so far, or will have taken? 3 that she's already taken, plus the T more that she has to take. So here's her total number of points. Here's divided by the number of tests, and it's telling us that our average will be a 90. And then we want to solve this. So this rational equation, because I can just put the 90 over 1, how can I solve it? Cross multiplying. We're not going to do it. But you would cross multiply to solve this one, making sure, most importantly, that you're distributing your 90 to the 3 plus T, and then solve. And T has to be a whole number, right? Because what if you said she had 4.2 tests left to take? That doesn't make any sense. She has to take 1 more test, 2 more tests, 3 more tests, 4 more tests. It has to be an integer. Okay? I'm more concerned with the setup here, not the solving, because we already should know how to solve pretty well. Let's jump down to this one. A group of friends agrees to equally share the cost of a $50,000 yacht. Before the purchase is made, 1 more person joins the group and enters the agreement. As a result, each person's share is reduced by $2,500. Write an equation to determine how many people were in the original group. So, let's talk about what was originally going to happen. A group of friends was going to equally share the cost of $50,000 yacht. So, a $50,000 yacht was going to be split into how many parts? We don't know. However many friends were in there initially, we'll say F for number of friends. So if it was divided into 2 friends, obviously each would pay $25,000. If it was divided into 3 friends, each would pay $16,000. If it was divided, this seems like a great way to buy a yacht, doesn't it? You can't all use it at the same time, but that's okay. You can you don't use it if you own it exclusively yourself. You don't use it all the time anyway. Just something to look into for your future. Okay? But if we split the $50,000 between all those friends, each one is going to, I'll use P for the payment that each individual person is going to make. That was the original situation. However, before the purchase is made, one more person is going to join the group. How is that going to change this? I'm going to rewrite a second equation. Mason? Right. You're now dividing the 50,000 by one more person. One more friend. As a result, each person's share is reduced by 2,500. What does that do? P minus 2,500. So we have two equations with two variables. What type of equation does that make? What type of problem? When you have two equations with two variables, it's called a system. Exactly. It's a system of equations with two equations, two variables, which is a pretty easy system to do by substitution, because if P is equal to this, I'm just going to plug that in for the P over here. So I'll have 50,000 divided by F plus 1 equals 50,000 divided by F minus 2,500. And it's a rational equation, and I'm solving for F. So as far as solving, and we're going to do this for a little bit, we're not going to do it all the way out, but the 2,500 goes over 1. And then what does this one need to accomplish the common denominator all the way across? F. So put your binomials in parentheses, and you can put your F in parentheses if you want to. This one needs an F over F. This one needs F plus 1 over F plus 1. And this one needs what? Right, it needs both of those factors. It needs an F over F, and it needs an F plus 1 over F plus 1. And then I'll be able to drop, drop, drop. So I'll have 50,000 F. I have to distribute this 50,000. So that's 50,000 F plus 50,000. And then on this last one, what do I have to distribute to the F plus 1? This whole thing. Negative 2,500 F has to be distributed. So that'll be negative 2,500 F squared minus 2,500 F. And that's obnoxious because it's just really big numbers. But it's what kind of equation is this that we have to solve? Quadratic, get it equal to 0. What can I do if I don't like these big numbers at this stage of the game? What can all of these divide by? 2,500. If you divide everything by 2,500, that's going to make it so much easier. 50,000 divided by 2,500 is just 20F equals 20F plus 20 minus F squared minus F. So much easier, right? So get everything equal to 0 and solve by factoring our formula. Okay? F has to be what kind of number? What did F stand for? The number of friends. Does it have to be a whole number then? Yes. Does it have to be positive? Yes. So if you get two answers here, make sure you're taking the one that makes sense. Okay? If they both make sense, that's okay. But it's number of friends, so it has to be an integer and it has to be positive. Okay? Any questions on that type? All right, a third type. Let me first make sure we all know this formula. Do you know that? Distance equals rate times time? Okay, write that down here. Distance equals rate times time. And we're going to use that. You're going to see how in a second. By the way, these are types of word problems that I have zero expectation that anybody would get right without having been taught it. There's some things that I know a lot of you are bright enough to figure out on your own. This is not one of them. Okay, so this is hard. Make sure, again, like I said on your homework tonight, you go back and look at the example that your homework question will parallel. A car can travel 300 miles in the same amount of time it takes a bus to travel 180 miles. If the average velocity of the bus is 20 miles per hour slower than the average velocity of the car, find the average velocity for each. My head's spinning. Let's start with the first fact that they gave us. The time it takes the car to do this. So the time, and I'll use a subscript for the car, is the same as the time it takes the bus to do its thing. So we want the time expression for the car to equal the time expression for the bus. Are you all with me there? Okay. So we're going to go back to this equation and we're going to solve it for t. So I'm going to divide both sides by r, and time equals the same thing as distance divided by rate. So now the time for the car, I'm going to replace time with the distance for the car over the rate for the car. And the time for the bus, I'm replacing the distance for the bus over the rate for the bus. And they gave me information about those two things. What was the distance the car traveled? 300 over. What was the distance the bus traveled? 180. Did they give us the rate of either of those two? Not exactly, right? They didn't give us what either of their rates were, but they did give us what their rates were relative to each other. They said that the velocity of the bus, so the rate of the bus, is 20 miles per hour slower than. So what am I going to call the rate of the bus versus the rate of the car if the bus is going 20 miles per hour slower? Nate? We'll go X. Correct. So we don't know their exact rate, but we do know that the rate of the bus is 20 miles per hour slower than the rate of the car. Good? Now, is that easy to solve? Cross multiply, right? We're not going to do it. It's the setup that I'm concerned with. Are we good with that? Okay, flip it over. This one's using the similar formula. So distance equals rate times time. I'm going to put over on the side because it's talking about distances and rates and times and so on. So let's read it first to get the general scope of what's going on. You ride your bike to campus, a distance of 5 miles, and return home on the same route. Going to campus, you ride mostly downhill and average 9 miles per hour faster than on your return trip home. If the round trip takes 1 hour and 10 minutes, that's the key. That's what's going to give us our structure. That's 7/6 of an hour, by the way. What is your average velocity? Okay? So the total time. So the time to campus plus the time back from campus, so your to trip and your return trip, your total time is 7/6 hours. Does that make sense? Your time to campus plus your time from. So now I'm going to go back. I need an expression because I don't know how long it took me to get to campus. All I know is the distance to campus, and I know a little bit about how fast I was pedaling on my way to campus. So I'm going to replace the time here. Again, I'm going to divide by r on both sides so that time can be replaced with distance over rate. Yep.
Can you do like the triangle method with
You're going to have to show me that in a minute.
Okay.
I'm not sure what that is. It sounds like a cute little name that a teacher gave to you at some point to help you remember, which it may be great. I just have never heard of it, so I'll have you show it to me in a minute. So the time to campus is going to be the distance to campus over the rate to campus, plus the time from campus is going to be replaced with the distance from campus over the rate on your way back from campus. And now we can start plugging in what we know. So, I don't know. Kaylee McCadden, give me one number to plug in one location. Good. To campus, a distance of 5 miles. So that's 5. I'm just going to set up my structure. What else can I plug in where? Raise your hand if you have another place. Cameron. Yeah, the distance back from campus is the same. They went on the same route. So if it took 5 miles to get to campus, unless there was an earthquake that separated the locations, it's going to be the same distance on the way back. How about next, Mason?
9 out of the first 5. R2.
Did they say we went 9 miles per hour on our way to? 9 miles per hour faster. Well, it was 9 miles per hour. Let's think about this. You may be right. I got to think about it. 9 miles per hour faster than on your return trip home. So which one is x and which one is x plus 9? This one is x plus 9. Then on your return trip home. Good. So going to campus, you were 9 miles per hour faster than on your return trip, which can just be x. Perfect. And we've written the equation. So when we get a common denominator on every single term, what does this one need? An x, what else? And a 6. What does this one need? This one needs an x plus 9 and a 6. And what does this one need? X. I'm going to do the x first. I'll get the monomial done first, and then the x plus 9. Remind me, what did x stand for again? The rate, the speed going home. Perfect. The rate going home. So keep your feeler out for that. So your rate going home has to be a positive number. Agreed? Can it be a decimal? Can you be going 5.5 miles per hour? Sure, that's fine. So when we solve this, we're ready to drop our denominator. What's this going to be? We'll actually solve this one out. What's 6 times x times 5? 30x plus. What am I distributing to my x plus 9 here? 30. So it'll be 30x plus 270 equals. What am I distributing to my x plus 9 here? 7x. So that'll be 7x squared plus 63x. Now what kind of equation is this? Quadratic. So I'm going to get it equal to 0. So this is how many x's total are on the left right now? 60. So I'll subtract that 60x over to the right. and I'll subtract this 270 over to the right. So I get 0 equals 7x squared plus 3x minus 270. Now, I could play around with factoring. I could do the quadratic formula. I don't know whether or not factoring is going to work. The quadratic formula always works, although those are pretty big numbers. How can I use my calculator to cheat in solving this? Nate? Graph it. So I'm going to type in 7x squared, and more importantly for the rest of you guys, how does the graph, where are my solutions going to show up on the graph? Everybody else but Nate. What did you say? On the zeros, exactly. So if I do zoom 6, here's what I see. Now, I'm missing the lower half of this. Why? Because my y-intercept's at negative 270. So if you really wanted to see, you could go down negative 300 to 300 on your y-axis and you'd see your better parabola. But x is a rate, so I'm only interested in the positive answer. Second, trace, find your zeros. Scroll way over here, left bound, that's to the left of that 0, hit enter. Now it's going to ask for my right bound, so I'm going to scroll my cursor to the right of that answer, enter, enter. So I've cheated, and I now know that one answer is 6. So there's my rate from campus. What's my rate to campus? $15. 9 miles per hour faster than that, 15. So for the record, I just cheated and used my calculator, but if I'm going backwards, what would have been the factor that would have made x equals 6? X minus 6. And now that I know that one factor, what would this term have to be to make 7x squared? 7x. And then you'd figure out that this has to be plus, what's 270 divided by 6? I'm just showing you that it was factorable. It probably would have taken me quite a long time to come up with that. So I cheated. I found the root from my calculator so I could get the one factor. So especially if they want you to solve something by factoring and they dictate that, you can use your calculator to kind of cheat factor. Good? Any questions? Okay. Last one here. You have 35 hits and 140 times at bat. So right now, your batting average is 35 hits out of 140. That's your current batting average. Comes out to 250, this tells us. If I divided that, I'd see 0.25. How many consecutive hits must you get to increase? So this is my number of hits. This is my number of at-bats. Obviously, the more you know about baseball, the better this is for you. But I'm looking to change my batting average to become .300. So how is this going to change? What am I trying to figure out here? Nate? Right, so I need to get how many more hits? There's my plus x. What else has to change, though? The bottom. How so, Mason? Right, if I get X more hits, I have to get that many more at-bats, right? You can't get a hit without stepping up to the plate and getting another at-bat. So I need to get X out of X more hits out of at-bats to get to 300. You could do the same thing with free throws in basketball, right? If you currently are shooting 70% from the free throw line, that's like 7 out of 10. How many consecutive free throws would you have to make in order to up your average to, let's say, 90%? You can't just say, oh, I just would have to make 2 more, right, to make that a 9, because you can't make 2 more without taking 2 more. And 9 out of 12 wouldn't be good enough. So you do plus X. You have to take X more shots in order to make X more shots to up it to 90. Does that make sense? Maybe, maybe not. Okay. So that would be, again, just a cross-multiply type. You don't need to worry about getting a common denominator on a cross-multiply type. So we didn't get to the last one, which means on your homework, you are to skip number 2. Oddly enough, number 2 is circled anyway. So skip number 2. I will make sure that that kind of word problem is not on your test tomorrow. Okay? If you have any questions on these homework questions, again, go to your notes, go to my video, and they all have an exact parallel on the notes that we just did. If you're really struggling, I'll be in tomorrow morning. Or you can send me a remind message and just show me your work, and then I can kind of comment on why it's not working out.